Hey class, we're gonna go ahead and talk about the real number system today. The reason I feel like we should talk about the real number system is because it talks about all the different types of numbers that we're gonna use this year. So I feel like you need to know those numbers before you can actually use them. Okay? I have my mask on because I want you to remember to show your work. All right? All right. All right, here we go. So first off, we're gonna talk about the natural numbers. Okay? The natural numbers are one. They start with the number one and they continue on forever. One, two, three, four, five, six, seven, forever, right? And so there's a theory, kind of a history theory about where the numbers first came from. And one of those theories is the number of angles in the number. So I'm going to show you that right now on the board. Okay. So we're going to start with the number one. Look at the number one. How many angles does it have in it? One angle, right? And then the next number is the number two. Two angles, right? And then number three, four, five, right? Two, three, four, five, six. The number six. And the number seven is that's where that line comes from in the number seven, right? Did you see people draw sometime? One, two, three, four, five, six, seven, right? They had to distinguish between the number seven and the number one. Number eight. One, two, three, four, five, six, seven, eight. There's the number eight. And then the number nine. Now the number nine comes from whenever you see people writing their nines like the letter G. One, two, three, four, five, six, seven, eight, nine. And there's the number nine. So we have the again. These are not the only natural numbers. These are the numbers that started all the numbers that we know today, right? We start with the number one, two, three, four, five, six, seven, eight, nine, 10, 11, 12, 13, 14, 15. I put the three dots right there. That's an ellipsis. That means it continues on, right? It keeps going. These are the natural numbers. They keep on going. So here we go. Okay, so the natural numbers start with the number one. Remember, that's going to be one of your questions, right? On the quiz. So natural numbers start with the number one. That means the natural numbers are one, two, three, four, five. And these three dots means it keeps going, right? It keeps on going. So after five is six, seven, eight, nine, 10, but no decimals or fractions, right? No decimals or fractions, just the numbers that we can count on our hands, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they're all the way until forever. Those are the natural numbers. Okay? I know that's kind of crazy, right? To think about that. That's where they came up with. That's a theory, right? It's not exact what people, what it maybe would actually happen. It could be, but it's just a theory. Okay? Now we're going to talk about the whole numbers. Now the whole numbers come from the idea of zero, right? So whenever numbers were first being discovered, like these, right? They didn't know what zero was. I mean, they didn't have a symbol. They knew nothing, right? But they didn't have a symbol to represent nothing. And that's where the number zero comes from. So here we go. Zero. How many angles does zero have? None, right? And so that's why it has no angles. That's why, that's one of the theories, right? Zero has no angles. So the whole numbers begins with the number zero, right? Zero, one, two, three, four, five, six, seven, and the three dots means it keeps on going, right? So zero, when it starts with the number zero, those are the whole numbers. And what we're talking about now is sets of numbers. The first set that we talked about, the first set of numbers we talked about is the natural numbers that began with the number 1. Now we need to find out a symbol that represents nothing. We needed to figure that out. The world needed to figure that, and that's where they came up with 0. And that next set of numbers is the whole numbers. And notice that the natural numbers are inside of the whole numbers. If you covered up the 0, what would happen? What would you have? You would have the natural numbers. So again, that's why we're going to draw another circle. This is what we're drawing. What we're drawing here is called a Venn diagram. It's named after a man that his last name is Venn, and again, that's why it's called the Venn diagram. He's the one who discovered it. So go look that up. Now, again, natural numbers, whole numbers. After they discovered 0, they discovered a symbol that represented nothing. Now they have to come up with symbols that represent when somebody owes you something. That's where the negatives come into play. Let's go ahead and let's get started. So we're going to deal with the integers. That's where the integers come in. The integers are all the negatives. Negative, all the way to negative infinity, negative 1 million, negative, all those negative numbers. And that's what the 3 dots represent. The 3 dots in the left direction. And then we're going to start with -3, -2, -1, 0, 1, 2, 3, and forever. That's 4, 5, 6, 7, 8, 9, 10. All those numbers in that direction. So it's all the negatives, zeros, and positive. Notice I have not mentioned decimals or fractions yet. No decimals, no fractions in the integers. You got to keep that in mind because that's the most common mistake is to think that there are decimals or fractions in integers. There are not. Okay? So those are the integers. And notice that the whole numbers, if I covered up the negatives, what would it be? Whole numbers. If I covered up the 0 and negatives, it would be the natural numbers. So that's why these are inside of the other one. Okay? Now, after they figured out the negatives, well, actually just all around, the numbers, the natural numbers, and they figured out 0 and they figured out all the negatives, now they got to figure out a way to represent parts of a whole. Also negative parts of a whole, right? So they got to think about the negatives. They got to think about parts of a number. And that's where the rational numbers comes in. Sometimes you will hear the rational numbers. The rational numbers sometimes are referred to as fractional numbers because they are fractions. So let's write this down. The fractions, I'm going to move over here. Fractions can be negative. There can be negative fractions, and the rational numbers, right? -1/2, 1/4, -3/4, 3/8, -2/7, right? You can't have negative, and there's also decimals in the rational numbers. The first type of decimal is terminating. What that means is that the decimal stops. They have a stopping point, like 0.25, 0.8, 0.625, right? They have stopping points. You can have -0.37, right? And then you have something called repeating decimals. That's where the decimal repeats. 0.333333 forever, right? The other way you can write this is 0.3 with the little dash above it, and that's 0.3 repeating. Okay, and you can have -0.7, -0.77 forever, right? You can have negative repeating decimals as well, and these are the rational numbers. And you can have percents. I'm gonna write that right here. Percents are also rational numbers. So that again, let's recap really quickly. The first type of number we talked about, the natural numbers, right? They continue on forever, but they start with the number 1. Then we discovered 0, right? The whole numbers start with 0, and they continue on forever, just like the natural numbers. And then we figured out we need to come up with a way for us to represent owing people money that's negatives, zeros, and positives. Still no decimals or fractions. Then we discovered parts of a number. That's where we get the rational numbers, okay? Now, there is another set of numbers called irrational numbers. We'll talk about those later. But right now, this is what we're going to be dealing with the real number system. Thanks for watching, guys.